Hello, good evening, everybody. Can you hear me?
Good evening,
Can you hear
sir.
me, please? Good
We can hear
evening.
you.
All right. I hope you had a beautiful day.
Yes, we did too.
Okay, so I like us to get started. Where did we stop in our last meeting? A reminder, please. Can somebody remind us where we stopped in our last contact?
We stopped at correlation,
Okay.
tie ranking,
Say that again.
tie ranking.
So we looked at ranked correlation, right?
Yes, sir.
What's that? Did we not go beyond that?
We
We
introduced regression.
Sorry?
We introduced
Stop
regression.
aggression.
I'm thinking we did ranked correlation and then we did the product moment correlation, right?
yes, sir.
All right. So, and then I had asked you to go back and complete a study on those measures of central tendency and dispersion. Is that correct?
Yes, sir.
Okay. So, let's very quickly run through, we'll very quickly run through regression today, and then see how far we can go. Another place we have to touch, which is very important, is those financial statistics. So, but before we do that, we'll have to have a look at regression. Now, if you would, um, let me see. Of course, measuring regression, we okay, measuring regression, we use firstly the graphical approach where we plot what we call the scatter graph. We do a scatter graph, and from the scatter graph we are able to determine line of best fit. I'm going to do something tonight that I like to, let's see how we can take advantage of technology to do some of those things we have to do this night. I'll open an estimation software from where I'll do a scatter plot, then how we can use that to determine regression. See the line of best fit. In regression, what we are actually looking at is how do we fit a line of best fit? How do we put up a line of best fit? So from there we can predict variable behavior. So I'm going to share my screen with you right away and then deploy an estimation software that we can use to make a scatter plot. Okay. Can you see my screen? Can you see my screen?
Yes, sir.
Yes, sir.
Yes, sir, we can see this.
All right. I have a series of variables. Okay, let me just make use of 3. These are my series of observations. I have credits, loan deposit ratio, and reserves covering the period up to from 1981 to 1986. Now I want to make a scatter plot of this. Do not worry about the process, but I want to use that to illustrate. Okay, then I want to fit a regression line. I'm plotting first versus all. So like my x is, my y is credit, and my x1 is LDR, and my x2 is reserves. So I just do okay. Now, can you see my screen? Can you still see my screen?
Yes, sir.
Can you see the result on the screen? Now, if you can see the result on the screen, you will see the scatter. You will see the various scatter word plots. For the relationship between credits and reserves, the regression line is the red line. While for the relationship between loan deposit ratio and credit, the regression line is the blue line. Are we together?
Yes, sir.
Yes, sir.
Okay, so if from here you can predict the relationship, the nature of the relationship between reserves and credit. It means they have a positive what relationship. Now it indicates that the highest point here of reserve produced the highest point of what credit. The highest point of reserve produced the highest point of what credit. You know, when you have that, you are looking at a positive relationship. As indicated, this is what we call the scatter plot, and then this is the regression line. And then for the relationship between LDR and credit, you will see the shape of the curve as well. Can you see that it is more like a proportionate relationship where credit almost remains the same at all levels of LDR. So it's a proportionate relationship, and then this is a progressive relationship, and this one shows a progressive relationship, and this shows a proportional relationship. You know, if it slopes this way, say this way from left downward to right, it shows a regressive relationship. You know, so that's how we can use a scatter plot to fit a regression line. That's one method of measuring regression. You know, fitting a scatter, doing a scatter plot. You know, this is a scatter plot, or you call it a scatter graph. So that's one. I don't know whether that's noted.
Yes, sir.
Yes, sir.
So first method is what? The use of scatter what? Graph. When you plot the scatter, you will see the various scatter. This is, at this point, we have credit is 7799 and reserves is 2578. If you bring it to this point now, you'll also see it. Like this is a mechanized process. Once you bring your points to the scatter, to any of the scatter, it shows you what credit is at that point and what reserve is at that point. If you do the same here, it tells you about LDR and credit. You know, so that's this it's a software, an estimation software actually that I'm using to do this. So instead of going to do all the plotting and then manually do it, you know, maybe in an exam setting, if maybe you're given a graph, a scatter plot, and then you're asked to explain the nature of the relationship between a certain variable and a certain variable. So you'll be able to say whether it's a progressive relationship, a regressive relationship, or a proportional relationship. You know, it's regressive when the two variables rise at the same time, they move in the same direction. Then it is regressive when they move in opposite direction, they are inversely related. Then it is proportional when it looks like they share equal and opposite form of relationship. You know, so as exemplified by this blue line. So that's that. Then the next way we can measure. I want to close the screen if there are no questions. Close this particular screen if there are no questions. before I move to the next stage. I just want to see go as fast as I can go in dealing with this. Any questions thus far? Any question? Like you're given a set of variables and you're asked to determine the relationship between a certain variable and a certain variable using a scatter plot. I think you should be able to handle it. That's one. Then secondly, I'd like to move to the next point. The next point is determining regression using the equation method. You know, the commonest method of this of measuring fitting a regression line using equation is the OLX. You've heard of OLX before?
Yes, sir.
What's OLX?
Ordinary least squares.
OLX is ordinary least squares. Ordinary what? Least square. You know, it's called OLX because that's the one that minimizes the sum squared. That's sum squared error. Sum squared error. The one that minimizes it. The one that gives you the least squared error. That's why it's called OLX, and it does appear to be the most efficient of all the other methods because it gives us the least sum squared error. You know, like sum squared deviation. So if it deviates less, it becomes more reliable than other methods. So that's the OLX. And then before we go to the use of the OLX, you will always remember. Can you still see my screen?
Yes, sir.
Yes, sir.
What are you seeing? A blank screen?
Blank screen.
Okay. Now you will always remember that there is the simple regression, and there is also what? The multiple regression, right?
Yes, sir.
Is that okay? Now, in a simple regression, you remember that you are looking at y as a function of what? Just an x. Then in a multiple regression, it's a different kettle of fish. Y is equated to more than an x. You know, in a multiple regression, y is equal to a function of or a script x1 x1 x2 x1 x2 x3 then maybe up to xn. You know, the explanation here is that you have multiple regressors You have multiple what? Regressors. Remember, there was something I told you in our last discussion that the correlation of x to y is the correlation of y to x. When you're looking at correlation, it's just linear association. There's no driver, there's no driven. But in regression is a different thing altogether. In regression, there is what we call a regressor, and there is what we call a regressand. That means you are explaining something on the basis of another. So in this circumstance, or maybe following our example or the standard practice, y is the regressand, while x is the what? The regressor. So when you have y explained by one regressor, you are looking at what? A simple what? Regression. So when you say simple regression, it is not simple in the sense of the regressand. It is simple in the sense of the what? Regressor. So, but when you are looking at multiple regression, you have y equated to more than one regressor. As you can see here, we have x1 is a regressor, x2 is a regressor, x3 is a regressor, down to xn. So in the case of a multiple regression, you have several what? Regressors. While in the case of simple regression, you just have one what? Regressor. So in simple regression, you have one regressor, while in multiple regression, you have what? Several, two or more regressors. Okay, now the same way we tried fitting a line of best fit using the scatter plot. We also can try fitting a line of best fit. This time around, not using a scatter plot, rather using an equation. But a standard equation model, regression model would read something like this. Let me write it so that I can pick it up from there. Now, a standard regression model will read something like y equals, you will have, okay, I got a script. Beta 0. In the case of a simple regression, it will just be beta 1 x1, or just beta 1 and then what? X. Now this is a simple regression. Now, meaning that in a simple regression, what are you going to be looking for? You'll be looking for, ordinarily, the x is given, right? The x is what? Given. And then the y is also what? Given. What will be missing will be this 1 and 2. The B0 is called the constant. The B0 is called what? The constant or the intercept. The B0 is what? The constant or the what? Or the intercept. While B1 is called, B1 is the slope of x. B1 is equal to what? The slope or coefficient of what? X. Now, you know why it's just stopped at x? It stopped at x because you're just looking for one x, since it is a simple what? Regression. Assuming it's a multiple regression, okay? In the case of a multiple regression, we will have something like this. In the case of a multiple regression, we'll have something like this. So here, we have a repetition of more than B1 and X1. Okay, let's say, okay, Now, I need to script this. So I would now have here as x1. Okay. I should do it this way. So I will have x1. I will now have b2 and x2. Then I'll have b3 and what? And x3. Are we together? Now this becomes a case of what? A case of multiple what? Regression. Now, one. But in multiple regression, I am looking for one, the constant, then two, the slope of x1, three, the slope of x2, and then the slope of x3, right? Do I still have your attention?
Yes, sir.
Yes, sir.
Okay, so you now see in the case of multiple regression, you have bigger axis to grind, more axes to grind in the case of multiple regression. So all these things will remain the same, but rather you now have more parameters. These are called parameters. X1, X2, X3 are called parameters. They are parameters that explain what? Parameters that explain what? Hello? Hello?
These are parameters that explain why.
Parameters that explain what? Why. They are parameters that explain why. So in this case, we have x1. This will be x2, which will be okay. V2 becomes the slope or coefficient of what? X2, coefficient of x1, and then here becomes B3. Then B3 becomes the coefficient or the slope of what? X3. Now question, what is this B0? What is B0? Now B0 is the constant or the what? Intercept. Now it is the value of y when all the parameters are held at 0. So B0 is the value of y when all the parameters are held at what? 0. When all the parameters are held at 0. For example, if B0 is 100 and then B1 is 0.2, B2 is 0.3, B3 is 0.4, and then X1 is 0, X2 is 0, X3 is 0. What will Y be equal to? What will Y be if B0 is 100, then B1 is 0.5, B2 is 0.6, B3 is 0.7 or whatever, and X1 is 0, X2 is 0, X3 is 0. What will Y be?
100. 100.
Y will be what? Y will be 100. Y will be 100 because if you multiply whatever B1 is by 0, it will give you 0. Multiply whatever B2 is by 0, it will also give you what? 0. Multiply B3 by 0, it will by whatever X3 is. If since X3 is 0, it will also give you 0. That means this will be 0. And then the only thing Y will be equal to will be what? The constant. So, and that's why we define B0 as the value of Y when all the parameters are held at what? 0. When all the parameters are held at 0, if I can ask you this as a CBA question. The value of Y in a regression when all the parameters are held at 0 is what? It becomes the intercept. The intercept is a value of Y. I can write intercept, constant, slope, coefficients, and all those blah, blah, blah. So you need to understand that the value of Y when all the parameters are held at 0 is what? Is the intercept, or the what? Or the constant. Now I want to give you a simple example before we go into estimation. There's a particular concept where this is massively applied. For example, how many of you know of cost concept? How many of you have heard of cost concept in economics? Where we say that TC, which is total cost, is equal to FC we say TC, that is total cost, is equal to FC plus VC. What's FC?
Fixed cost.
Fixed cost.
FC is fixed cost. What's VC? VC is what? Variable cost. Now I can rewrite this equation to read like this. If you want to write this equation in an estimable format, Y, which is the fixed cost, is equal to A plus BQ. Why? Are you getting what I'm saying? Y, which is this is more like a regression model. What you have here is a regression model. In fact, a simple regression model. In fact, you can liken this to this first equation. Take a look at it. Is there any difference?
No, sir.
No difference. Now, this B0 is the constant which you can attribute to the word fixed cost. And then the B1X is like BQ. That's B is variable cost per unit, while Q is quantity. Now, the question is, what will total cost be when quantity produced is 0? If you're a producer and then you are producing at 0 level, what cost will remain? There's only one cost that will remain when you are producing at 0 level. When your output is 0, there's only one cost that you can have, and that cost is what?
The fixed cost.
Fixed cost.
That cost is the what? The fixed cost. And if you can liken it to this, my explanation, you now see that the constant is what remains when all the other parameters are held at what? 0. So when output is held at 0, the only cost that remains or that you can incur is the fixed what? Cost, because fixed cost does not vary proportionately with the volume of what? Output. Only variable cost does. Variable cost varies, not just vary. Note that it doesn't just vary. It varies proportionately with what? With the volume of what? Output. I can ask you that as a multiple choice question, that's as a CBA question. Simple regression in cost concept can best be illustrated by what? By the relationship between fixed cost, variable cost, and what? Total cost. So don't forget that. So these are real life applications of what we are talking about. So in the light of that, I think we can at this point move into estimating a simple regression model. estimating a simple, I may like to have a run through on the example I've already given in your manual. Let's just do a run through with that example so that we can save time and move on. As you may all be aware, the semester is gradually winding up, and it is my desire to make sure I touch everything that should be touched. Let me see if I can get out that example, just copy it and paste it, and then be able to have a run through with it instead of spending a lot of time generating and solving fresh examples. So if there are areas you have questions, you just raise them, we'll trash them out, and then keep moving on. Let me pick my examples from the manual, and then we'll have a walkthrough with them. Because as much as we can, I want us to see if we can finish regression tonight. Are you seeing my screen? What are you seeing?
Still seeing the document one.
Okay, what I was sharing, that you're still seeing that, okay.
Yes, the y equals a plus b q.
Okay, let me start a new share. So what are you seeing now?
Study session 2.
Okay, fine. All right, so this is the scatter plot. I've spoken about that already. Okay. Now, if we are looking at a simple regression, like I told you, you are actually interested in looking for two things, and these two things are the B0 and what? B1. The question will always be like, you want to fit a regression line. And fitting a regression, one of the roles of a regression model is that it is a predictive model. You can use, you may have something in your multiple choice, something like, which of the following models is a predictive model? Somebody puts regression, somebody puts correlation, somebody puts one or two other things. But just know that regression is a predictive model. It has the capacity to predict Y for given levels of X. So in the light of that, you are, like the question you may be asked could just be, you're given a regression model already fitted, and then you're asked to predict certain things or explain certain things from it. And another example likely can be, you are asked to fit the line yourself. You're asked to create the equation yourself. Now, ordinarily, if you're fitting the line, your interest would be, in the case of multiple regression, to get B0 and to get what? B1. So to get B0, see the formula, I highlighted it in red. You have it in your manual. Summation of x squared, summation of y minus summation of x, summation of xy. Now, one thing you should note is that the denominator for B0 and B1 are just what? The same. They share the same denominator, if you can notice it, and summation x squared minus n summation x all squared. Then for B1, it is the same denominator. Where they vary is in the what? Numerator. Take note of that. So if you would remember the denominator for one, you will remember the denominator for the second one. And then when you fit the regression line, or after fitting the regression line, in the case of multiple regression, if you are looking for B2, the formula changes in the case of multiple regression. It will appear thus, and as you see here, then that's x1y, x2 squared. You know, you can run through it. It's contained in your manual. Now, this example, we have an illustration here. The question says, establish a regression line with GDP as Y and CPS as X. Predict GDP when CPS is 10 million. Then the next question is, establish also a regression line with GDP as Y, CPS as X1, M2 as what? X2. Now, can anybody tell me the difference between the first and the second question? What is the difference between the first and the second question?
The first question is simple regression.
Beautiful. And then the second one is what? Multiple regression. Because you have more than one what? X. Always bear that in mind. So when you are giving more than an X, you are looking for multiple what? Regression. When you are giving one X, you are looking for what? Simple. The same table can be deployed to. But then let's see, to get, when you just know what you're looking for, you create your table. This is Y, X, XY, that is GDP multiplied by CPS, then Y squared and X what squared. These are the things you are looking for to be able to get B0 and B1. Now, having arrived at B0 and B1, what you just do here is to fit your regression line, which is that GDP is equal to 1.07, which is the constant as found here, plus 4.88 predictive model. This is what you use to predict. That means tell me, when CPS is equal to 0, what will GDP be?
7.
Hello?
1.07.
1.07, okay? When GDP is, when, in fact, you will see where this model was used to predict CPS equals 10 million. Okay, that's the first one. Then the second, in the second this, we have this you know, you have to follow through as well, and then get your B1, get your B2, then get your B0. With that again, you fit your regression line. After fitting your regression, you can also use it to predict GDP at given levels of CPS and M2. Now, I like to very quickly talk about this because examining this topic, there are two things I may likely do. I may give you an estimated model and ask you to do explanations of all these things. I may also ask you to, if I would ask you to estimate, I'd be better off with stopping at simple regression. Very speedily. There are three tests we are exposed to, you know, which helps to show the validity of the result we have, the validity of the regression model. Now, the first one is the test for goodness of fit. The second one is the test for significance of the overall regression. And the third one is the test for significance of the parameter estimate, and the test for significance of the overall regression, the test for the significance of the parameter estimates or the parameters, and then the third one is the test for goodness of fit. How do we test goodness of fit? Well, what is goodness of fit? Now, I'd like to return to my okay. Now, in looking at this test for goodness of fit, then 2, test for significance of the overall regression, then 3, test significance of the parameter estimates. Now, when we are looking at tests for good, the R squared, and adjust. And R bar squared. Now, R squared and R bar squared, they are used to test what? To test goodness of what? Fit. Now, R squared is what shows us, they show us what we call the explained variation. Listen very closely. They show the one. Let's also understand that the first two are joint statistics. The first two are what? Joint statistics. And then this last one is a test of individual parameters. Now, why are these first two called joint statistics? You know, they are commonly found when you are doing, they are most commonly used when you are doing multiple regression. Most commonly found in multiple regression, because you are looking at the capacity of all the variables put together to explain y. Remember, all the x are explanatory variables and they are meant to explain what? Y. Then what is their capacity to explain y? How capable are they to explain y, or to what degree can they offer explanation about why? You know, so they give us what we call the explained variation, which is the amount of change in y that is jointly accounted for by all the x. Did you hear what I said? Can you still hear me?
Yes, sir, we can.
Okay, so I said it is the amount of change in what? Y that is jointly accounted for by all the what? X. Like the case of M2 and CPS explaining GDP. The question now is, what is the percentage of explanation in GDP that is responsible, that M2 and CPS are responsible for? Now, if the anyone not explained by them is called the unexplained variation. Is called the what? Unexplained variation. For example, if your arrow squared is 90%, if your arrow squared is 90%, so what would be the if arrow squared is 90%, it means 90% is the EV, that's the explained what? Variation. Then what would be the unexplained variation? Unexplained variation would be equal to 100% minus what? 90%, which would be what? 10%. So in case you are given the explained variation, you are giving the to find the unexplained variation. The highest possible likely variation is 100. So if arrow squared is the explained, then anything not explained becomes what? Unexplained. So that's important. Now, it is believed that the higher the arrow squared, the better the goodness of fit. The higher the arrow squared, the better the goodness of what? Fit. If you go through your manual, you will see these things discussed. Okay, now, arrow squared and adjusted arrow squared, they almost do the same thing, but the only thing is that adjusted arrow squared is a tighter fit. It makes provision for the inclusion of more explanatory variables. Then the next overall joint statistics rather is the F statistics. What does the F statistics show? It shows the statistical significance. The statistical significance of the overall regression. The statistical significance of the overall what? Regression. In other words, is the overall regression statistically what? Significant? If it is statistically significant, it means it can be used for meaningful analysis. If it is not statistically significant, it means it cannot be used for meaningful what? Analysis. It is useless. It has no base. So F shows us how statistically significant the model is. Is the model good enough for meaningful analysis, or is it not? Now, we usually check the F calculated versus the F tabulated. F cal versus F tab. If you go through your manual, you will see it discussed. F cal versus F what? Tab. If F cal is greater than F tab, we will reject the null of no significance and accept the alternate of what? Significance. If F cal is greater than F tab, reject the null hypothesis of no significance and accept the alternate hypothesis of what? Significance. Okay. Now, in the use of estimation software, there is what we call the probability value of F. I will show you that shortly. I will show you these things in an estimation software very shortly. So, but I want you to understand it both ways. Understand the statistical estimation as you can go through in your manual. I'll also demonstrate for you the use of estimation software to do this. And how you, in case you're given an estimation software and asked to interpret it like an MBA person who is supposed to be a manager, in an organization, most times this thing gets to your table and they come by way of figures and results. And then yours will just be to analyze them and use them to make meaningful decisions. You must understand the parameters for analyzing, and that's the method or the ways of analyzing this result and make decisions out of them. So, and even for you as students that are planning to do your research, and then nobody expects you to begin to use your hand to calculate regression. The kind of variables or the kind expected to use cannot warrant your sitting down to calculate regression. I remember what happened when I did my MSc. I had to gather data and I was using my hand to demonstrate how I can statistically estimate regression. When I finished and carried it to my supervisor, he looked at it and laughed. He asked me, Ebere, why suffer for nothing? Why do you do for yourself what something else can do for you? That he instantly rejected. I said I should go back and then look for an estimation software to do my work and then be able to expand my data stretch. So that is important. It's very, very important. You don't shy away from it. Shy away from the use of estimation software to estimate your result, especially when it has to do with your research, because definitely most of you will be expected to go along the line of empirical research where you'll be expected to do estimations and interpret results. That's by the way. But then for the basic and for the traditional way, we have F calculated versus F tabulated. And that determines whether the result is significant or not. Then lastly, we have test of individual parameters. This one is done using what we call the t-statistics. The t-statistics handles that. So that's what we use to test. Now, the test of the individual parameters shows the significance of the explanatory variables, the significance of the regressors, the individual regressors, their significance. That's what the test of the individual parameters is all about. And it is done with the what? With the T-word statistics. Don't forget this. In your multiple choice quiz, from what I'm our discussion here now, I already can generate quite a number of questions from the things I'm telling you. Which parameter, which test is used to check the significance of the individual parameters or the explanatory variables. You should know it's a t-test. Which one shows the significance of the overall regression? You should know is an f-statistics. Which one shows explanatory? Which one is the explanatory? Shows explained variation? You should know is r squared. How do you determine the unexplained variation? You should know that it is 100% minus r squared. 1 minus r squared, 100% minus r squared gives you the unexplained variation. So details of what you are supposed to look at in t-statistics is also contained in your manual. But just realize that t is used for the test of the significance of the individual parameter estimate. So when t is right, it means the parameters are good explanatory variables. Maybe the particular parameter, the particular variable is good enough to explain the dependent variable. And it shows you the degree of explanation that it can offer, about the explanatory, about the explained variable, that's about the regressand. So it shows you that too. So that's the much I have to tell you here. That means you have to go back, look through the processes, especially with the illustrations as contained in your manual. Then I'd like to very quickly do something before we get out of this place and then see whether I can make an introduction to the other, the business statistics, that's financial statistics. Can you see my screen again?
Yes, sir, we can.
Yes, sir.
I've left the Microsoft environment.
Yes,
I am using an estimation software now. Okay, now I want to estimate regression using an estimation software. Let's assume from this result, I am taking credit as my dependent variable, and then I'm taking this reserves, loan deposit ratio, and then probably shareholders fund, because I want to do multiple regression. I am using 3 independent variables and 1 dependent variable. Then I want to get, okay, now I'm using least square. If you're using the estimation software, you have several other types of regression. Using the simplest, which is the least squares, and I just click OK. Then I have a result here. Can you see this result? Can you see what's on my screen?
Yes, sir.
Please, if you don't have noise on your background, you can unmute yourself so that I can be saying yes when necessary. All right. Now from here, I'd like you to give attention to something. See the R squared. Okay, let me pick this result over to a Microsoft environment so that I can say more about it. Okay, you can see it. Can you still see the result?
Yes, sir.
Fine. Now,
Yes, sir.
I like to talk about it. Firstly, you can see the R squared. What's the R squared from there? From what you can see,
0.968.
the R squared is 0.968, which you can roughly say is 0.97, right?
Yes,
R
sir.
squared is 0.97. That's about what? 97%. So what's the explained variation? The explained variation is what? 97%. Then the adjusted R squared is what? We can take that to be 96.5%, right? 96.5%. That's the adjusted what? R squared. So what's the unexplained variation?
Hundred minus
3%.
100 minus 3%.
3%.
Unexplained variation is what? 3%.
3%.
Now you can see the F. You can see the F. Let me lift it. Here is the F statistics. Now, 2 things. If you use an estimation software, 2 things are given to you in the F statistics. One is the F figure, and then 2 is the probability of the F statistics. The F statistics and the probability of the F what statistics. Now, this is the F this is the F calculated. This is what we call the F cal, which, if you like, you can go to the table and then draw inference with the F tab and the F cal. But I don't do this. You don't need to do this, because 2 decision rules here. There are 2 decision rules in the use of the F. Number 1, of course, we know that the hypothesis, the null hypothesis, is that what? The overall result is not significant. The overall result is not statistically significant. The overall result is not statistically significant. And then the alternate is that the overall result is what? Statistically significant. Fine. Now, if you want to interpret this, there are 2 rules. The first rule is the rule of thumb. The rule of what? Thumb. Now, by rule of thumb, if F is greater than 2.5, reject null by rule of thumb. You know what's rule of thumb? What is rule of thumb?
Generally accepted.
It's more like rule built out of convention. It may not be evidence-based, thorough evidence-based, but it works. Rule of thumb. So by rule of thumb, if f is greater than 2.5, reject what? Null. Then another rule, that's rule number 1. Another rule is the use of p-value. The use of what? P-value. Now see the p-value of f. When you do f test, you normally choose a level of significance. Am I correct? You normally choose a level of what? What are the levels of significance we use in carrying out statistical tests? What are the levels of significance? So, tell me. Number 1 is what? We can do at 1%. We can do at what again? Can you still hear me?
Yes, sir.
1%. What's the next one? We can do at 5%. And we can do at 10%. Now, when we do at 5%, okay, well, let me make a short table here. Now, this is level of significance. And then this is confidence level. Now, if you do at 1%, your confidence level is 99%. If you do at 5%, your confidence level is what? 95%. If you do at 10%, your confidence level is what? 90%. Now, let me explain this. You want to reject, the desire of every researcher in his tests is to reject null. You plan to reject what? Null. But then you want to avoid error in testing your what? Hypothesis. Now, because you want to avoid error, you create acceptance region and what? Rejection what? Region. And then you also create for yourself what should be your level of significance. You're more like saying, okay, at 1%, if the observed error is greater than 1%, I will refuse to reject null hypothesis. Now that means I want to be 99% sure that I am not rejecting null hypothesis in error. That's why this is your confidence level. Then if you say I am going to function at 5% level of significance, you want to be 95% sure that you are not rejecting null hypothesis in error. If you're operating at 10% level of significance, you want to be 90% sure that you are not rejecting null hypothesis in what? Error. So in the light of that, but by standard practice generally, 5% is very often used. 5% is most often used as a level of significance. Now, except you're told otherwise. Like I can give you an exam question and ask you to make your decision at 10% level of significance. All right. Then, going back to this decision rule, the p-value This p-value is seen as the actual error. The actual error is the p-value, while the standard error is the level of significance. The standard error is the level of significance, while the actual error is the what? P-value. So what's the decision rule? If okay, let me not use standard error so that it doesn't confuse things. That's the set or just level of significance. P-value is the actual, while the level of significance is the standard. Let me use it that way, so I don't confuse the regular standard error with level of significance. Actual error is the p-value, while the level of significance is the standard. So, and then you are saying if the actual is greater than the standard, reject null. Otherwise, refuse to reject null. So, and in the light, that's why each time we look at the p-value and the p-value is less than the level of significance, we'll just say the result is good. For example, we're looking at F statistics here. By the first rule, which is the rule of thumb, 2.5, this F statistics is 349.8175 is already greater than 2.5. You notice that? And then looking at the probability value is 0, 0.0000. While your level of significance can be anything here, it could be 0.1, 0.01, 0.05. So whichever way you go, they will all be less. That means the actual is less than the what? The standard. Therefore, we will what? Sorry, if actual is greater than the standard, refuse to reject null. Sorry. If actual is less, it should have been less rather, not greater, please. If actual is less than the standard, reject null what? Hypothesis. So in the light of that now, p-value here is 0.00000. That's the actual. And this actual is less than 0.05, which is the standard, less than 0.01, less than 0.1. So in the light of that, we can reject null and conclude that F is, that the overall result is statistically what? Significant. Now, each time the p-value is less than the level of significance, it means the overall regression is statistically what? Significant. Each time the p-value of F is less than the level of significance, it's an indication that the overall regression is statistically what? Significant. Now, I'm going to stop this class now, but I had wanted to see if we could finish this, but I think it's almost 11 o'clock. Can I still take the next 15 minutes and round it off?
Yes, sir.
Do you still have the patience to continue?
Yes, sir.
Okay, now I have explained R squared, I've explained F statistics. Now, if you come here, let's move up a little. Now, these are the joint statistics. Everything here is called joint what? Statistics. But then here we have the individual parameters up here. If you look at it very closely, we'll see reserve is a variable. RDR is a variable. Shoulders for us, SHF is also what? A variable. Can you see C? What is C? Tell me. What is C? Remember, we didn't select any C when we were doing our imputing our result. We didn't select. We didn't select any C, but the C appeared. This C is that B0, that is the constant. The C is the what? The constant. Now, if we are going to fit, I like to fit, let's get the regression equation out now. Let me go back to that result and get the regression equation. Okay. Here is the regression equation. Now, this is the regression equation. That credit is equal to, this is the constant. Oh, sorry about that. This should have come up here. Here's the constant now. Now that this is the constant, and then here is the coefficient of B1 multiplied by reserves, plus coefficient of B2 multiplied by LDR, plus coefficient of B3 multiplied by SHF. Here is the regression equation. Now, one of the things I may ask you, if I am giving you a result like this, I may ask you to create the regression equation out of this result. Now, if you're asked to create the regression equation, it's just that the dependent variable is equal to constant plus this SHF plus this plus this, just like I illustrated here. Don't forget that. Now, not all these variables are statistically what? Significant. Not all of them. Not all of them are statistically what? Significant. In fact, for a start, let's see what the coefficient tells us. What does the coefficient tell us? Reserves has a negative coefficient. Can you see it? Is it true?
Yes, it is.
Then LDR has a what? Positive coefficient. SHF also has what? A positive coefficient. What does that tell you? It means that as reserves increase, credit what? Drops. As reserve increases, credit what? Drops. Then it means that as loan deposit ratio gets higher, credit also what? Gets higher. Then as shareholders fund gets higher, credit also gets what? Higher. So if the coefficient has a negative sign, it means it varies inversely with the dependent variable. If it has a positive sign, it means it varies directly with the dependent what? Variable. Don't forget that. All right. Now, these are the coefficients, but are they significant? This question will be answered by the what? By the T. The T, the same way we have the F and the probability of F, we also have the T and the probability of what? T. Can you see that? This is T and the probability of what? T. It also follows the same decision rule. It follows the same decision rule as what? F. For example, the first one, the T is less than 2.5. You can see it. And then the p-value is about 97%, which is far greater than 0.05. So in the first one, the T is not what? Reserve is not a significant function of credit. So it means reserve is not significant. Not the first one, not what? Significant. NS. I wish I could fix it in Let me see. Okay, let me just add another column. Add another column to be able to fix it in. So here, the first one is what? Not significant, NS. Then the second one, is the second one significant? Talk to me. The first one is not significant. Why? Because P is far greater than 5%. And then T is less than what? 2.5. Then the second one, is it significant or not significant?
Significant.
What's the P? The P is 61.4%. If the first one is not significant, the second one is also not what? Significant. And then the third one is T is 7.76 and P is 0.0000. Is it significant or not significant?
Significant.
Is significant. Then lastly, we're not interpreting the coefficient. So you can see when P is less than 0.05, that's the probability is less than 0.05, it is what? Significant. When it is greater than 0.05, it is not significant. Now, what is our interpretation? Reserves is a negative and non-significant function. Credit is a negative and non-significant function of reserve. That means reserve does not significantly affect credit. Then loan deposit ratio also does not significantly affect what? Credit. But shareholders fund significantly affects credit. So I've said some things here. One, how you interpret the T, what the T does and how you interpret it. I've also said how you interpret the R, how you interpret the F. And I've also showed you how you can extract the regression equation from a result such as the one we have above. So I'll expect you to go back and look through your material as well as this extra material I've discussed with you tonight. Then you'll be able to come up with your question maybe in our next class. Or if you can raise them now, you can go ahead and raise them. But with what I have done thus far, I can assume that I have said the much I can say on regression. In my next class with you, I'm going over to financial statistics.
I have a question, sir.
Please go ahead and ask your question.
Is it safe to assume that the decision rules that the use of p-value takes preeminence over the rule of thumb?
They have this. They give you the same answer.
So
That's if you use.
There's no way there will be different.
They can't differ. They have never disagreed, and they have never. They will never disagree.
Okay, sir.
So can you ask more questions? Please ask me. Or you want to go and digest and bring the questions next time? We have like the next 5 minutes to address questions. Raise your questions. Are you people sleeping?
I have one more question.
Okay, that's
What's
Jacob. Go ahead.
Yes, sir. The name of the statistical software you're using.
The what?
Your software, the statistical
Okay,
software.
I use the eViews.
Sir,
I use
thank you, sir.
eViews 10. Any other question? Chijoke, any question?
None for now, sir.
Chinasa, any question?
None, sir. Let me go and digest it too.
Please buy water. Chame, any question?
What I'm wondering is all these plenty formulas that are very complicated, are we going to be asked during exams to? That's what I'm trying to, because they're so complicated.
Your question appears tougher than the exam itself.
the plenty formulas are too complicated. So I'm asking, as in, are we meant to get all that into our head before the exam? Like, because there are plenty. So I don't know.
Well, the antidote to that is you practice. When you practice them, you wouldn't even know when you internalize them. But that's one side of it. Then the other side, like I've told you, is chances are that you may be given results and asked to interpret. You know,
Yes.
so
Okay.
it can go both ways.
Oh, it can go both ways. It can't go one way. Okay, sir.
No, there can't be one way and the only way. Only
Okay.
Jesus is the one way and the only way. Sorry.
Okay. Okay, sir.
Okay. Any other question? Any question, Danny?
No,
Dr.
no.
Joshua? Dr. Joshua, any question? Joseph, Moses, any questions? All right, so please go and look through what we have done. And then by our next meeting, we'll go into financial statistics, which is an important aspect of this because it's actually business statistics. Actually, business statistics. So those financial statistics are things you must also be able to put in. So I'm thinking maybe like 2 or 3 more contacts, I'll be able to wrap up. 2 or 3 more contacts, I'll be able to wrap up. I can say for sure that your group seems to be the group I've gone the farthest with. You know, maybe because of the lockdown, the exam did not come at the time it should. So it's looking like we are trying to touch everything. So we have 2 more things to do. Then financial statistics and inventory management. So once we're able to touch these 2, we can as well say we've covered everything. Right, so in the light of what we've done thus far and also the fact that there are no questions, I'd like to bid you good night and ask you to stay safe.
Thank you, sir. Good
Thank
night.
you,
Thank you, sir. Good night, sir.
Good night, sir.